Yesterday I provided the presentation to you and also the video, right?
Yeah. If you can share this information with me, that would be helpful.
Yeah. And because I try a lot of time with the zygomatic case, so I find out if I follow this protocol, I mean the steps, that will be more easily to training the both zygomatic implant or even the folds. Okay.
Good.
Yeah. So because we know for the treatment planning always come to two different parts. One was the surgical treatment. And it means when the doctors they press the implant, they did not have the processes, the STL file, right?
Yep.
So what I do is to asking the surgeon to press the bone screw, not only for the trace registration purpose, and also press the bone screw where can guide us to press the implant. Okay, so for this case, if you need, maybe I can send the model to you or send the STL file to you, because I create the model like this one, and it's can for the like our the GC break or the duck holiday, it can to do the zygomatic the.
So just to understand, okay, this is a training module, or you produce a module per each case?
Yeah, no, I only create this one for the training model.
Okay.
Yeah. So.
And you're placing the screws. What the purpose of the screws? The screws is to just to get registered. It's the mini screw protocol that you're applying.
No, not only for the trace protocol, and also for to let us know where I can press the implant. Because so in this case, it's the fully dangerous. I don't have the position where I can put the implant on the first molar or close to the second premolar.
Okay, so you basically, in this case, you do have teeth, but in reality you don't, and you place screws where you're gonna place the implants.
Yes, correct.
Yeah, but these are not zygomatic implants. These are standard implants.
No, it's for the zygomatic implant.
But I can see there are 4 screws that you place. 1, 2, 3, 4 screws.
You mean the bone screw here?
Yeah. So you
the
said
total I remember was. Yes, please.
You said that these screws mimic where the implants are placed. Yes, but these are not. Yeah, these are not zygomatic implants. Maybe the anterior ones are straight implants, while the posterior are zygomatic.
You mean if the anterior is a zygomatic?
No, posterior.
Yeah.
Zygomatic. Anterior, straight.
Yes.
Okay.
Yes.
Good. Yeah.
Yeah. And for the version 2.1.1, I will do twice to making the jaw curve. First, of course, to make sure the distance, including the teeth or the bone screw for tracing.
Yeah.
And the second time, I will move the curve up to the zygoma base, the area. But in the version 3.0 or 3.0.1, I only do once to marking the jaw curve, because I think that is we change the offset to 15 millimeter.
Yep.
Okay. Yeah. And before I placing the implant, I will make sure all the landmark I can to decide which one I will using for the tracing purpose.
Yep.
Okay.
Yep.
Yep. And the next, when I start to press the imprint, I will add to both sides the imprint, the regular one, and in our setting that is 4.0 by 10. So I add two implant, and because when patient take the CBCT, I press the bone screw. So now I can very easily to identify where is the location, like in the right region, it means it's the first molar. And for this bone screw, it means the second molar.
So you basically plan the implants on the screws.
Yes, yes.
Okay.
And of course, you can move the implant to the second premolar. It's just a reference, If the patient is the fully dangerous or the teeth was helpless and have to remove during the surgery. Yeah, because after we do the transrestoration, we can remove the bone screw.
Yep.
Okay. And next step, I will, okay. And in this step, why I said I will put the two imprint in the right hand side or to the left hand side. That because if we put the imprint number one and then make it to 42 or 52.5 length and turn to the zygoma bone, it will make us more difficult to press the second imprint. So the first step, I will press the two imprint at one time.
Okay. Let me ask you a question on this picture. I can see on the quadrant on the bottom right that there is the shape
Yep.
of the implant.
Yes.
Yeah, but there is no screw. Why?
Okay. Yeah, because you can see here was the imprint number 2.
Yes, but there is no screw. You said that you're gonna place the implant on the screw. I cannot see the screw
Okay.
there.
Okay, here. Back to this one. And that I say is will press the bone screw in the first molar or second molar.
Okay.
Okay, so for the imprint number 2 here, I place this bone screw in the left region. It's the second molar.
Okay.
Okay, so
Oh,
for the
so but
number one,
so you basically
yes,
you place the screw, but the implant is not necessarily on the screw.
yes,
It's
correct.
nearby the screw.
Yes, correct.
Okay, good.
And it's of course in the planning stage, it's much easier to define where is the location. And
Okay.
if we are doing the surgery, it will also help us to find where is the entry point because it provides a guide for us.
Yeah.
Yeah. Then next, you can start to increasing the length of the implant
Yep.
and turn the implant to the zygoma.
Yep.
And now I will using the not only the section view and also the model view here
Okay. Yep.
to move the imprint. Okay.
Yep.
So basically, this is the surgical driven because we do not have any processes to guide us where the abutment to tilt out. Okay.
Yep.
So again, then after the imprint number 1, we go to the imprint number 2 to do the same steps.
Yep.
Okay. And now we have another solution for the patient come with the STL file and will be
Yep.
much easier. Okay, so this is the original, maybe the conventional impression, then scan to the STL file, or the
Yep.
doctor who have the internal scan. then they can superimpose the original intrascan file into the new dentation and become the new one.
How do you superimpose one with the other? Do you have some landmarks or what?
Okay, and it's very easier. Let me share with you another presentation. Okay. No, not this one. Give me a second, sorry. Do you know the Mesh Mixer, the application?
Mesh Mixer, yes.
Okay, and basically I'm using the Mesh Mixer.
So you're not using some landmarks on the
No,
two
you
sets?
don't have. Okay, here.
Yeah.
Okay, and you can see here was two different STL file, right? A
Yeah.
surgical scan and the intra scan. Then how to make to become the one file. So you just need the drop into different STL file, and it will combine automatically. You don't have to do anything.
So you
Then
just, it does the matching automatically?
Yes, yes.
Based on what? Based on the fact that they've been scanned on the same arch?
Basically, I don't know how they can do this, but I just put the two. Oh, okay. What I'm thinking is because when the technician they do the processes planning, basically they are based on the internal scan, right?
Yeah.
So I think it might be they have some STL file proficient, like the technology language they can superimpose back easily and
So,
automatically.
but let me square this, Eric. So you get these files from the lab technician.
Yep.
So the lab technician scans the base plate, then the other prosthetic items, and then provides to you with information. So basically, what does the lab technician? He scans, so he imports into his own ExoCAD software. He imports his STL of the jaw. It imports the setup, diagnostic setup,
Yes.
and in using a mesh mixer, it does the
Yep.
superimposition one with the other.
Yes.
The question is, what is the key? Because these are two different sets. One is the anatomical set, and the other is the prosthetic set. What would be the key for him to join and superimpose the two data sets?
I don't know, but the
Okay.
technician always know how to do this.
Yeah, would be interesting if you can ask the question and eventually get some sort of an idea of what would be the means that he applies in order to do the superimposition. Because at the end of the day, that's very crucial. A good superimposition of the two data sets is very helpful from the planning standpoint.
Yes, and before I go to the next protocol, I would like to share another one for you. This one, okay? And you can see it's a conventional and convert to the digital part.
Yeah.
Then for the fully residential patient, they have the first step to collect the data in the vertical dimensions, right?
Yep, yep, yeah.
Uh, so how to collect the data and convert to the digital and allow the technician can decide in the digital software. And you can
Yep,
see using the WhatsApp, right?
yep.
And on the Zygomia board, and let the patient wear this WhatsApp and take the CBCT. After that, the doctor will send this WhatsApp and the model to the technician.
Okay.
And the technician have the landmark from the Zygomia, okay?
Mm-hmm.
And
Okay.
now, when they finish the prosthetic design, it will be very easier to
Yes.
superimpose back our Navident.
Yeah, that makes sense. Is this
Yep.
therefore the protocol that is followed?
Yes.
So it goes through the analogic models where
Yep.
the vertical dimension is understood, and there are,
Yep.
I can see radiopaque spots, which
Yep.
then can be used to do the matching with the diagnostic setup.
Yes.
Okay, good. Now I understand. Yeah.
Yep. Okay, so let's back to here. And
So in
then
other,
this the same.
sorry, Derek. So mix mixture doesn't help in that case because it does with the models, radiopaque landmarks, and then
In
basically
that case,
does.
I did not use the match mixer. No, in that case, I don't need use the match mixer.
Okay, okay, good.
Yeah, in the first one, it's not necessary. And I will say, almost we don't have to use in the match mixer because the technician they have the more powerful software like the 3Shape or even the
Yeah, yeah,
SOCAD or even a blue sky bio.
yeah.
Yeah. So match mixer just from our side to help a doctor who can more easier to use. But I will say always asking the doctor to ask their technician.
Yeah.
Okay. And the step one and the step two is same.
Mm-hmm.
And now we start from because we have the STL file,
Yeah,
then we can support those together. And for this case, I was using the keys for the lemon.
yeah.
In the next step, when I back to the main screen, I will hiding the 3D region first because it will helpful to only show the STL file because
Yeah.
we have already superimposed the STL and the CPCT.
Yeah, but this is something that you do before planning, because I haven't seen the plan, the implanted planned, the one that you tilted zygomatically is not there in this picture.
Yes,
So this
yes.
stage
So
is taking place before implant placement.
now this is the second solutions. I separate two parts. First
Okay.
is the surgical driven with only the CBCT and without the prosthetic STL.
Okay.
And the next
So
one, and
so
when we did the ST,
the first part applies when there is no diagnostic setup.
yes, correct.
When there is no diagnostic setup, you apply the first solution. If you do
Yes,
have a prosthetic setup, you apply the second solution.
correct.
But ideally, the second solution is far better than the first one.
Yes, of course.
Okay, good. Okay, so you basically, now you matched the diagnostic setup to the
Yep,
anatomy.
yep,
Okay,
yes. And before I place the implant, I will hiding the 3D region here. And you can only see that only shows the STL file. without the CT.
Okay.
And then again, I press the 2 imprint at one time.
Mm-hmm. So in this case, you do have on the top left quadrant only STL files. You don't have any COMBEAM dataset.
No. I have the combine, but for the planning easier or more efficiency, I will hide in the CT.
Okay. Why it is easier if you hide the CBCT? Why?
Okay. Because when I try to make sure where is the occlusal, it means where the abutment come up. You have to know from the occlusal view, right?
Yep.
And if you have the CT here, you will see too much information because maybe you have the
Okay.
lower jaw.
Okay. Good. Yeah. I see what you're saying. Yeah.
So again, after placing the implant and increasing the length, and before I turn or tilt the implant to zygoma, I will add the abutment first.
Yep.
Basically, because so far we have the 2 or 3 the zygoma implant in the market. First is the Nobel Biocare,
Yeah.
and I also know there is Norris, right?
Yeah. Norris and Southern Implants.
Okay, yes, South implant, and because they have like the straight type or the 45-degree or the 60-degree for the platform.
Mm-hmm.
So I make an example here is the 45-degree from the Nobel Biocare.
Yep.
So before I tilt the implant to a zygoma, I will add a 45-degree abutment here.
Abutment. So you identify the library, the Nobel library, and you place a Nobel 45 degrees abutment.
Yes. If the doctor will placing the 45-degree abutment here.
Yeah.
Because this is a one piece, right?
Yeah.
And now here it's easier than us to know where the implant or the abutment screw come up the locations.
Yeah.
And also we can check from the 3D view here.
Yep.
Then now you can much easier to move the imprint from the 3D here.
I see.
After that, I will check from the um, red section view from the platform to the text to make
Yeah, the
sure it's
sagittal view.
full. Yes, the sagittal view. Yes, correct. From the occlusal to the zygoma, because you can also check the relationship with the maxilla sinus.
Yep. Yep.
Then after the implant number 1, I will go to implant number 2 and follow the same steps again.
Yep.
Okay, increasing length at a 45 angle abutment and tilt the implant.
Yep.
Remove the from the 3D view.
Yep.
Yeah. So basically, this is what I do right now in Taiwan.
Okay. Then you place the jaw tracker, the bone jaw tracker.
Yeah.
Yep.
And I would like to show you one more if you still have the time.
Yes, please.
And because this is the handsome model, right? So I also could make a video here.
variabili qualitative, quindi informazioni qualitative. Nel caso in cui avessimo informazioni quantitative, queste possono essere
So now is this
messe
accurate registration?
registrate direttamente senza dover essere prima quantificate. Generalmente si utilizza per considerare valori
And then the accuracy check. And we do some modify for the drilling sequence. We will use the regular.
You do what? Repeat. Say it again.
We do some modify.
Of what?
Of the drill sequence.
Okay. What's the modification there?
Okay. From the beginning, we were using the lens or the pilot drill. And because it's much shorter, like the 18 millimeter, it will be much easier because some patients still have the lower jaw teeth or have some problem with the open mouth limitations.
Yep. So you use a short. You will what?
Short drill.
A short.
Short drill. Yes, short drill.
Short. 18 millimeters short.
Yes.
Okay. So you
when
first
I approach
use the short millimeter drill, and then what?
Then approach to the zygoma. Then
you change the drill.
The zygoma.
And you use a zygoma drill of what length?
I have to check the dimensions.
Mm-hmm.
And this is the reason why I'm using the short drill here, because the zygoma bone was very hard.
Yeah.
And we have to create an entry point first.
Yeah.
So if in this stage, using the zygoma drill, the longer one, it will much difficult.
Are you using a straight handpiece?
No, a contra angle.
You're using a contra angle.
Yes, but I find another one handpiece will much easier for placing the zygoma implant. I will send you the handpiece information later.
Okay, good. Is it a contra
it's
or is a straight one?
It's a contra angle, and it's from the WNH, but I cannot find in Taiwan market. Maybe you can find in your market.
Okay, good. Yeah.
I sent it to your WhatsApp.
Yep. Yep, got it.
Yeah, these handpieces were very helpful. It's from WNH.
Yeah.
Yeah.
I see that. Yeah.
So yeah, so it's what I do in Taiwan market now. Yes.
Okay, good. Good.